Hi and welcome. Today we're going to talk about the properties of a negative binomial distribution. So the probability distribution function for a negative binomial is listed right there. And just three properties I want you to know is that the moment generating function is p to the t divided by 1 minus q e to the t raised to the r. The expected value is r over p. And the variance is rq divided by p squared, where q is 1 minus p. Now, I'm just going to talk about fact number 2 and fact number 1, how they relate to each other. So, we should recall that the expected value is just the derivative of the moment generating function. And that's what we're going to prove. We're going to prove fact 2 using fact 1. Now, one thing that you might notice about the moment generating function is it looks very similar to a geometric distribution. And later in the course, we'll learn that if x and y are independent random variables, then the moment generating function of the transformation, the sum of x plus y, is equal to the product of the moment generating function of x times the moment generating function of y. And this tells us that the moment generating function of a negative binomial is related to a geometric. In fact, it is just repeating a geometric distribution r times. And when we think about the hypergeometric being the random variable being the number of trials until observing r successes, that is exactly repeating the geometric distribution r times. Now, let's prove that the mean of x, being mu, is r over p. Well, to use that, we're going to use a previous fact, which is that the mean is just the moment generating function evaluated at 0. So here we have the moment generating function when we take the derivative. So we take the derivative p e to the t divided by 1 minus q e to the t raised to the r. Okay? We need to use the chain rule to take the derivative here. So I bring the exponent down r, I replace it with r minus 1, I keep what's inside inside. Then I multiply by the derivative of the inside function, which we must use the quotient rule. In using the quotient rule, we take the derivative of the top, which is itself, multiply by the bottom. Then we subtract the denominator, but there's a double negative coming, making this a plus. So plus q e to the t, because the derivative of 1 minus q e to the t is just minus q e to the t, the negatives cancel. So we get plus q e to the t times p e to the t, and we squared the denominator. Now, one more fact is that p plus q is 1, so that will tell us that p is going to be 1 minus q. So a useful fact is that p is 1 minus q, e to the 0 is 1. When we take this derivative and evaluate it at 0, I'm going to get r times p times e to the 0 divided by 1 minus q e to the 0 raised to the r minus 1 times p e to the 0 times 1 minus q e to the 0 plus q e to the 0 times p e to the 0 divided by 1 minus q e to the 0. Okay, now let's simplify this. This will be r times p. 1 minus q in the denominator is p as well, so that'll be 1 to the r minus 1 times p times, well, 1 minus p is going to be p plus q times p divided by p. Remember, 1 minus q is p. Okay, well, we're almost done at this stage. So this will be r times, well, p squared on top plus p times q. But remember, q is going to be 1 minus p divided by p. And I apologize, there is one typo. The denominator here needs to be squared, right? So we need to square that. My apologies. So this will be r times, well, p squared plus p minus p squared divided by p squared. And then finally, this will simplify to be r over p. Okay, and that is the expected value. So it's important to be able to use these three facts. Some problems will ask you what is the mean. Some problems will ask you what's the variance. And perhaps in some situations you may need to prove or use the moment generating function of a negative binomial. Thank you.